Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
I'm Ariana for Math Homework Help Call in Bakersfield 636-4357. Everywhere else 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, Ariana, nicely done. So where do you go to school?
Stockdale Elementary.
Stockdale Elementary. And what grade are you in?
4th grade.
Do you like going to school longer now because you're in 4th grade?
No.
You don't? Oh, I wouldn't like it either. It's like, hey, I used to only have to go until 2 or 3 o'clock. Now I have to go an extra half an hour. So you're not cool with that?
No.
Well, guess what? You're going to have to get used to it, right? Because when you go to 5th grade and 6th grade, you're going to have to do the same thing. And guess what happens when you go to junior high or middle school?
I'm assuming it gets longer.
Yeah, you're going to get a little bit longer. And guess what happens when you go to high school?
Longer.
It's going to be even a little bit longer, but I'm sure it won't be like hours longer, but it'll be a little bit longer. So, do you enjoy 4th grade right now?
Yes.
What do you like so much about it?
Gate.
Do you like gate?
Yes.
So explain to me what that is, because there are some kids that are like, what are you talking about, gate? Like the gate that leaves school, or what are you talking about?
Well, GATE stands for Gifted and Talented Education. GATE is available for 4th, 5th, and 6th grade. And you learn foreign languages. For 4th grade, it's Italian. 5th grade, it's Spanish. And 6th grade, it's French.
Okay. So you like that part of it? You like learning the foreign language right now?
Yes, I do.
What else do you like about it, or what other kinds of things do you do?
Well, we do projects, sometimes art projects. Right now, we're doing a Greek mythology project.
Okay. And what are you doing for the Greek mythology project?
I'm making up a recipe based on a Greek god or goddess.
And which one?
Artemis and Apollo.
Oh, Artemis and Apollo. All right, cool. And do you like Greek mythology? Like, have you been doing that for a while, or is this something that you're just doing now? And
It's something that I'm just doing now.
so it's something that you're doing now?
Yeah.
All right, good. So I'm glad that you like GATE, right? Something a little different. How often do you do that?
GATE is every Wednesday.
So you go every Wednesday. So tomorrow you'll be going to GATE.
Yeah.
So maybe you can tell all the people in GATE that you were on Do the Math today.
Yeah.
No, not a bad thing right there. All right, you ready to do a little math?
Yeah.
All right, let's take a look at this problem today. This is the problem of the day that is posed to people on social media. So all that stuff you read before about Facebook, Instagram, Twitter, and YouTube, it goes out on some of those things. And kids and adults take a look at it, and they submit their answers, and then we see what they thought the answer was. So let's take a look at the problem together. So, well, they put the answer up there already. All right, so let's see how they got to that answer. So, all right, pretend you didn't see it. You didn't see that, did you?
I did.
I did. Well, I did too, but I didn't see it well enough, so let's, okay. So it says, find the value of 9 exclamation point divided by 7 exclamation point. Does that mean find the value of 9 divided by 7? Do you think that's what it means?
I'd assume not.
I would probably guess not too, all right. So do you have any idea what those exclamation points or marks mean?
No.
Okay, so those are called factorials, all right? So a factorial means you're going to take whatever number's in front of it and multiply it by all of the numbers underneath it until you get to 1.
Okay.
All right? So let's start off with 3 factorial. That would be 3 times 2 times 1. So what is 3 times 2?
6.
And 6 times 1?
6.
6. So 3 factorial would be 6. Does that make sense?
Yeah.
What about 4 factorial? What would that be? Explain to me how you figure out 4 factorial.
Well, it'll be 4 times 3 times 2 times 1.
Right, it would be 4 times 3 times 2 times 1. And what is that? Can you do, let's do it right in order. What's 4 times 3?
12.
And what's 12 times 2?
24.
And 24 times 1?
24.
So 4 factorial would be 24. Okay, so let's take a look at the problem again. It says find the value of 9 factorial divided by 7 factorial. So knowing that, what can you tell me about this problem right now?
Well, we'd have to divide, well, you'd have to, well, 9 times 8 times 7 times 6 times, and all the numbers.
Right, we keep on going, right? So we're gonna have to go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's a lot of multiplying, isn't it? Especially if we had to do it in our head,
Yeah, it is.
right? So we're gonna get a big number. And then what do we do with that number?
We divide it by 7 factorial.
And how do we find 7 factorial?
Well, 7 times 6, 7 times 5, 7 times 4.
Same
7
thing, right?
Yeah.
So there's an easier way to do this if we think about it. Can you think of an easier way to do this? Think about things that are common between 9 factorial and 7 factorial, and is there a way we can make it a little bit easier?
Well, common,
Common numbers between them both, right? So explain what you tell me what the common numbers are, or what are you talking about?
well, the common numbers, they would be 6, 5, 4, 3, 2, and 1.
Right. 6, 5, 4, 3, 2, and 1 are common in both of them, right? So they kind of cancel each other out, right? Because 6 divided by 6 would be 1. 5 divided by 5 would be 1. Is 7 common between them both also?
It does not have 7 times 7. Well, it has 9 times 7.
Well, we have 9 times 8 times 7,
Yes.
right? So the 7 is on the one with 9. Is 7 included in the bottom one also, 7 factorial? Don't we start with 7?
Yes.
So could the 7s be eliminated also? They could be, right? Because 7 divided by 7 would be 1. So what's left with 9 factorial that's not in 7 factorial?
No, 9 factorial. Okay, 6, 5, 4, 3, 2, and 1.
Right, those are all going to be in 9, right? But what's in 9 that's not in 7?
9 and 8.
9 and 8. And what is 9 times 8?
9 times 8 is 72.
Okay, take a look at what Scott wrote on the board, because as you were talking about it, he wrote down what you were doing. So he said 9 factorial was just as you said, 9 times 8 and all those other numbers, right? Mm-hmm. And then he did just as you said, 7 factorial was all those numbers. And what he did is he eliminated everything that was common. All right? So do you see what was left?
Yes.
What was left?
9 and 8.
Okay, and tell Scott what that is again.
Common.
It's 72, right? 9 times 8 is 72?
Yes.
And what's left on the bottom? Just a bunch of 1s, right?
Yeah.
So what's 72 divided by 1?
72 by 72.
So let's take a look at the options up here. We have 54, 81, 72, and 84. So which one do you think it is?
C.
You feel pretty good about that? I think you just explained it pretty well also. So let's take a look and see if the is the correct answer. And I know we had it up there, but people may not have noticed it or they may have gone, why is that up there? I don't know what this is yet. Let's go. So nicely done. First one all through. Nice job, Ariana. So now you know a little bit about factorials.
Yeah.
So you learned a little something already today, right? All right, nicely done. 636-4357 phone number is here until, we have phone tutors available until 5:30, most Tuesdays and Wednesdays throughout the regular school year. But big programming note. Today, the 28th of March, tomorrow, the 29th, the final 2 days for live broadcast for Do the Math for this season, our 21st season of Do the Math. So if you have a math problem that you would like to see worked out, you have today until 5:30 and tomorrow the 29th. And then we'll obviously be showing some of the past shows from this year during the rest of the school year, and you can always check them out on YouTube. But today and tomorrow will be the last 2 days of live broadcasts for Do the Math. Goes by pretty quick, doesn't it, the whole school year? Yeah, indeed it does. Hey, right now, time for today's Math in the News. All right, so slide down a little bit, Ariana. We're going to bring in a celebrity. Did you know we had a celebrity? This is our second celebrity today because you're our first celebrity, right? And in studio with us right now, we have Chef Justin Casey. Nice to see you today.
Nice to see you.
So, did you make us something? Is that why you're in here?
I did not.
Nobody kidding.
I didn't have time.
You know, the old fat boy here,
schedule-
you know, like, yeah, we got a chef coming in. Let's see what kind of food we got coming.
If I come back on, I'll try to bring some food with me next
Ooh,
time.
excellent. You know what? You're our first guest next year. So. All right, so you are a chef at ROC.
Yep.
And for students that are like, well, I don't know, what is ROC? What is ROC? What
So
is that?
ROC is Career Technical Education. We have juniors and seniors from all over Kern High School, and we teach them trades. So I teach culinary arts. We have a construction trades program, cosmetology, welding.
And there's dozens
on and
of
on
them.
and on. Yeah.
Because ROC and CTEC have been partners with Do the Math for a long time. And now the students that Lisa works with in the video production class
Yeah.
over there, they produce all of the videos and send them to us.
Some of the stuff that goes on both of the campuses is pretty amazing.
It is.
Yeah.
Now, I met you close to a year ago.
Mm-hmm.
And I met you at a beautiful Bakersfield Award.
Okay.
And you were receiving the award with the principal, Brian. And what was that award for?
So that was an award for the design of our facility, our culinary arts program, the restaurant, the kitchen, and just our building in general.
Right.
It was an awesome award to receive, and for me, it kind of just let us know how much backing we had in the community.
And
to do
where
what we
is
do.
that facility in case people are going, well, I don't know where
It's,
this is. I'd like to see it.
I didn't know where it was either until I started teaching there. 501 South Mount Vernon, just right off of Mount Vernon,
Okay.
East Bakersfield.
Now, you're talking about being a chef and the culinary skills that you're providing for these students.
Yes.
So, when they first come in and they go, yeah, I think I'd like to be a chef, how does all of that start? What are some of the courses or things that you go over at the beginning?
So for me, there's two parts of our program. I teach with another awesome teacher, Cyro Vias, who does all the baking and pastry
Okay.
part. So that's really not my expertise. Her training is different than mine. But for me, I focus on knife skills, measurement, and just really basics. But for me, I have to get the kids caught up on how to use knives correctly.
And that's a big thing,
yeah.
right? Because you don't want them taking their fingers off and stuff like that.
We do have to use Band-Aids sometimes. I always reiterate that it's not a home ec class. It's full of chef knives, slicers, commercial cooking equipment. So we spend a lot of time on safety, sanitation, a lot of things that we'll teach in the classroom in the beginning of the school
Okay.
year until we actually put knives in their hands, or until Miss Elvia starts really going over the things that she introduces the students for. We focus on work skills as well, resume building, punctuality, all those kind of things, and really try to build students into good employees, to be honest with you. So,
Okay.
and but for me, it's the knife work, and that's the part that I'm always the most excited about, and my students are really excited too. And I see massive improvement.
And this is the facility that you guys are at,
yeah,
right?
sorry, I just noticed that. So you guys are looking at our restaurant right now, kind of on a slower day. This winter has been challenging because of the weather, but we have a state-of-the-art kitchen, two of them.
I was going to say, it looks beautiful there. I mean, I've seen other kitchens at restaurants, and that looks no different than...
Yeah. So this kitchen, and not exaggerating, I mean, I've spent my entire life cooking. Since I was in high school, I finished high school and went to culinary school. I've worked in San Francisco and Seattle, all these places. The kitchen I have now is nicer than any kitchen I've ever worked in. Not exaggerating.
Now, what about the restaurant part? Because that is open to the public,
Yeah,
right?
and our students serve the tables, take the orders, put the orders in. They do everything, from the maintenance to our stoves to filling water, putting specials in the computer.
So
they-
you don't
they do
have
everything.
kids that are cooking in the back and
No,
taking
no,
care
no.
of people in the front.
No,
They
so-
do everything.
So what we do is we rotate the students. Right now, my responsibility is the kitchen and the front of the house, so the service side. Mrs. Elvias does the barista side, where we make coffees and lots of drinks. So I send 5 students at a time, 3 servers, a busser, a hostess. We do pretty quick training on the front part, and they start running the show. 2 weeks later, I rotate them. Those kids come back into my kitchen. New kids go out.
Okay.
Yeah,
well,
so it's
a real world setting, right? Kids want to know what it's like to work in a restaurant instead of just sitting at a class watching some videos or something like that and talking about it and maybe going somewhere once. They're
Yeah.
immersed in this all the time, every day.
They are, and they have to learn how to problem solve because just
And-
like in the restaurant business, things don't always go right.
And
or as
collaborating,
planned.
right? Something
Yeah.
happens out front, you need to talk to the people in back. Hey, this is what's going on, or something's going on in the back. They need to be able to deal with the people out front.
Yeah, and the kids are all working together, and I'm kind of like in between them when I need to be, and sometimes I do need to be, and sometimes they just completely
Take care of it
amaze me
themselves.
and just run the show themselves. Yeah.
Yeah. So once again, you need to be a junior or senior to be in this program.
Yep. And if you're a sophomore, applying as soon as possible is a good idea. Our program fills up very fast. Or if you're a freshman, to start thinking about it next year. When
So
you're a
how many
sophomore.
students are able
So
to
we
take the
have
class at a time?
we have 120 students.
Oh, wow.
2 teachers, and we have 2 different groups of students. We have an AM and a PM group.
Okay.
So my AM group, I have about 30 students. Miss Ovias has about 30 students.
Oh, so that's how you,
Yeah.
okay.
Yeah, and then we get another wave coming in.
So is there anything that you guys make that you think, wow, you know what, we would really like the public to come check this out because this is a pretty unique thing that we're doing here?
You know, I would say all of it. The pastry stuff always kind of wows me because it's just so good. And for me, I think that just watching the kids work is my favorite part about it.
So
I'm
when-
not gonna select a specific dish.
Okay,
Oh, come
so
for this.
when
but-
is it open? So obviously not in the
Yeah.
summertime.
So that's
'cause kids aren't
no,
there, right?
Yeah, so we operate when we have students, which is also a different situation than most restaurants. Is we're really scheduling our hours of operation to the students' schedules. if that
So
makes sense.
I'm not working at school one
Yeah.
day. I've got the day off and I want to go to ROC and check it out.
So Tuesday through Thursday, breakfast is served from 8:30 to 10 o'clock, and then lunch is served from 12:30 to 2 o'clock.
Okay.
Yeah, and it's a 3-hour block that we have these students, but we also have to factor in prep time and cleaning this massive kitchen and all of the other things. So that's one of our biggest challenges is availability.
And you got to clean it for the next day.
Yeah, exactly. Yeah, so that's
All
part of
right.
it.
Well, you know what? I think we have one more bit of footage to show, I think. Is this of the facility, I think? Oh, all right. Oh, okay. I thought there was something else. I was like, yeah, it kept on going. I was like, hey, we got something else to see. Anyway, Justin, thank you very much for coming in. How long have you been with ROC doing this?
This is my 4th year.
Your 4th year.
Yeah.
So you've got, what, like 30 more years to go? And
Yeah. I hope
But
so.
you'll stick
I-
around,
no,
right?
I love it. I love,
there you go.
love
Well, that's the
teaching
thing.
and-
Love what you're doing.
and getting to watch
right?
the
Do what
kids
you love and-
develop and come in with very little confidence and leave with a lot of confidence. And
especially the knife skills.
yeah, all of it. Thank you, sir. I appreciate it.
Thank you for coming in.
All right.
636-4357 is the phone number. We do have phone tutors available until 5:30. Ariana is a 4th grade student from Stockdale Elementary, ready to work on a little division. So if you guys would be so kind as to clear the board.
Just for you.
All right, so we have 34,238.
Try to keep your hand off there. There you go. Okay, 34,000.
So 34,238 divided by 17.
Whoa. All
So
right.
Ariana, go ahead and explain to Scott how you'd like to do it. If you get stuck, Scott's right there.
What do you think? Where are we going to start here?
Well, I start off with, I'm going to do 17 times 2 because 17 times 2 is 34.
Okay.
And so we have 34 right here. So.
Yeah. And I like how you put the 2 over top of the 4. That's pretty important. If you put it over top of the 3, 17 doesn't go into 3, really, right? So really what's there is a 0, even though you don't need to write it. 17 goes into 34, the 2's there. So go ahead. Okay, so where's that 34 coming from?
17 times.
Good. So 2 times 17, and you're going to put that underneath. All right, keep on going.
And then we drag the 2 down.
Bring down the 2. All right.
You can't do anything with 7.
Okay.
So,
So 17 doesn't go into 2.
it doesn't-
So what are you going to do about that? Oh, I like it. You got to put that 0 in there before you bring down another number, right? Good.
And so then,
All right, I'm going to switch you spots here, and I'm going to give you some more room. So keep on going.
then you bring down the 3.
Good.
17 goes into 23 one time.
One time, all right. You're going to put that above the 3. Good job. Okay, I'm going to roll this down here for you a little bit more. Good. You bring down the 8. Okay, what do you think? How many times do you think 17 goes into 68? That's a bit of a challenge, huh? When you figure it out, we can try to put it up there. We can kind of scroll back and forth here. What was the one that you did find out? We know that for sure 17 times 1 is 17. We have that one. The other one we had was 17 times 2, and that was 34, right? So it's got to be more than 2.
So it's going to be 17 times 4.
Times 4. Now, how'd you come to that conclusion? I think that's a wonderful way to look at it.
Because 17 times 2 is 34.
Right.
And so I just added another 34.
Gotcha. So 2 times and then 2 more times. Looks like we'll be pretty darn close. I like it. So we want to put a 4 up there, then I'll scroll it down for you so you can do the rest of it. Good. There you go. So 4 times 17?
68.
68. Good guess.
Oh.
That's great. I like it. And do you have a remainder on this problem?
No.
All right. So let's look back at the top here. What is your final answer at the top there?
2014.
2014. Now, if you had to bet money on it, or if you had to have it absolutely right no matter what, or if someone said, I will give you $100 if you get this right, for sure, for sure, for sure, and you want to make sure that is the answer, do you know a way you could check this answer to make sure it absolutely is correct?
I could do 2014 times 17.
That's right. If you did 2014 times 17 and work that out, what do you think the answer should be?
Could I do it in box method?
Sure.
Oh, wait.
There you go. Okay, so you're breaking this top number down, right? So the first column is going to be 2,000. Good.
Let me get rid of all those lines for you quickly. There you go.
Good. So this is 10 and 17. That's where that comes from. What's the next column? That's kind of interesting, huh?
Well, it would be a 0.
Nothing there, huh? Yeah, so you can put a 0 there. And then in the next column, and that's in the
10.
tens column. Good, so you got a 10.
And then I'm going to erase some of this.
That's okay. You can just squish it all in there, no biggie. What's that very last column going to be?
4.
Good. Okay, so tell me where these numbers are coming from. You got 4 times what?
7.
Oh, I got you. Okay, so it's like a multiplication chart. 7 times 4. All right, what's next?
I would do 10 times 4,
Okay, 10 times 4.
40.
Good.
And then 7 times 10, which would be 70.
Good.
10 times 10, 100.
Mm-hmm.
10 times 0 would be 0.
0.
7 times 0 would be 0.
0. Not much going on in that column, huh?
10 times 2,000 would be... I can't really fit that in.
Yeah, that's a lot of zeros, huh? So you got 2,000, right? And then another 0. So what is that number?
20,000.
20,000. Wow.
And then 7, I do 7 times 2, which would be 14, and
Uh-huh.
then add the 3 zeros.
Yeah, 3 more zeros. Wow. So what do you do with all those numbers at the end?
You add them all up.
Add them all up. That's it. So I added these two for you. That's 68. I added these two for you. You get 170. And now we can add those two together to get, oh, I don't know,
This one we don't really
a really
need.
big number, huh?
Yes.
34,000. Can you add those up real quick?
Yes. Like
8. Good.
6, 7, 13.
13. Got to carry a 1, right?
1.
1 plus
that's
1
a
is?
4, correct?
The 4's over there. Yeah, 4's over there a little bit further. This is that column right there.
Okay, so 1,
So 1 plus 1?
2.
2. Can you squish in a 3 and a 4 there?
Yeah.
Squeeze them in there. Good job. Is that the number you started off with?
Yes.
Wow, we're feeling good about that. So we always like to get that number when you check the number that you started off with in the very beginning of the problem. Great job going forward and what I would call backwards. That's
There you go. Nicely done checking that problem as well. So here's another little hint for you, because sometimes on standardized tests where you have to move a little quicker, let's say they had as answers. So maybe Scott, put down A, B, C, D
Sure.
over on the far right side. And let's go 2011, 2012, 2013, and 2014. Now, Ariana, those are all pretty close together, aren't they?
Yes.
And you only have a matter of a couple of seconds to figure out which one is correct. You are not going to be able to divide those out. But you have 34,238 divided by 17. Is there a way you might be able to do that quickly by looking at those answers that are close together?
Can't really think of, well, I can't really think of anything.
Okay, so maybe Scott can help you out.
So here's your original problem, right? That's all you're given. And this question says, which one of these answers is correct? And we don't know this yet. We're not sure what that is yet. All the other work you did was wonderful, but we want to see how we go this into this quickly. Okay, so here's the deal. Whatever you multiply this number by, 17, you're going to multiply it times the top like you just did, and we have to have an 8 on the end, right? You have to have an 8. So that last number, 7, times 1 in the ones column. What's 7 times 1?
7.
That didn't work. What's 7 times 2?
14.
14, and that ends in
4.
a 4. That didn't work. What's 7 times 3?
21.
21. That ends in
1.
a 1. Still doesn't leave an 8, right? What's 7 times 4?
7 times 4, 28.
28. Does that end in an 8?
Yes.
So that's one way you can look at that and say, you know what? I'm not maybe 100%, but I'm 99% sure this is going to be your answer, because that last digit will help you out to know that it will give you the last digit here if you multiply it together.
All right, just a little something that can be added to your repertoire
Yeah.
right there, so they can help you out as you're doing some larger math problems sometime, or to kind of check real things quickly and go,
Yeah.
all right, you know what, I got to move. I
It
know,
makes sense. That's
for
right.
different things. All right. Hey, do you like paper airplanes?
Yeah.
Yeah, who doesn't like paper airplanes, right? Get a favorite test or whatever and make a paper airplane and fling it. Let's check them out right now.
Have you ever accepted a challenge and thought, this is way too easy? So you didn't prepare? Hi, I'm David Alexander, and I wanted to share with you what it took for me and my friend James Ryan to design and throw a paper airplane more than 100 feet. Spoiler alert, we failed so many times, it was actually embarrassing. Here's the story. NASA challenged us to come up with a fun aeronautics-related activity where students design and throw a paper airplane 100 feet or farther. So we accepted the challenge thinking, what's the big deal? We fold a few planes, those planes will easily fly 100 feet, maybe even 200 feet, and we'll knock this out in 1 or 2 tries. Easy, right? We were so wrong. None of our paper airplanes even came close to 100 feet. Our designs vary greatly, and we threw each plane with all our strength, but the farthest we could reach was 62 feet. Yes, we took the challenge for granted, but maybe we could still pull this off. Our biggest problem was we couldn't figure out what went wrong, and we needed help. We thought, what would an engineer do? We recalled the very first step in the engineering design process is to ask questions. So my friend James contacted an aerospace engineer at NASA named Jesse Quinlan. So here's what Jesse said.
Hi, Jesse. How are you?
I'm doing well, James. How are you doing?
I need help. I don't know what I'm doing wrong.
Sure, James. Yeah, I'm glad you reached out. At NASA, we actually think about what it takes to make a great airplane a lot. We care about the world around us, and we believe in a sustainable future for aviation. So it's important for us to always be working toward aircraft concepts and designs that support this vision. And it's important in your case, you have a very small paper airplane. We need to minimize the drag however we can. And my first tip to you, just make those folds as tight as you possibly can, and especially the leading edge of your wings. So the frontmost surfaces of your wings, make sure those are nice and crisp. And I think we'll be able to reduce your drag a little bit and help us fly a little bit further. Maybe the most important tip I can give you here is related to stability. We want our CG, or our center of gravity, to be a little bit more forward than our aerodynamic center. So if you maybe have a paper clip or some tape, you could apply that to the nose. That'll help ensure that your nose wants to tend down instead of tending up, because what happens when your nose pitches up, you run the risk of stalling and dropping out of the sky like a brick. The one other thing that I'll say about this too is I don't think I saw any dihedral on your aircraft. Angle this wing up. Exactly. Hold that wingtip and just angle it up a little bit so that the wingtips are higher than the root. Exactly. Just like that. What that's going to do is it's going to make the aircraft have a tendency to roll stabilize itself. And so I think with those few really important considerations, you can probably achieve the paper airplane range of your dreams. So I wish you the best of luck, and I hope for many successful flights in your future, James.
Jesse's tips were exactly what we needed. Now, do you think the ways that NASA optimizes flight and makes aircraft more sustainable can help our paper airplane go the distance? There's only one way to find out.
He did it! No! He did it! He did it! Oh, yeah! Boys and girls, ladies and gentlemen, the moment of truth. We're actually going to find out how far of a distance he threw a paper airplane.
–
102 feet.
We finally got it to go past 100 feet. I'm so excited.
When we saw that paper airplane reach 102 feet, it was electrifying. When those sustainability principles were put to the test, they really worked. So we included them in an activity called Winging It. Maybe you can beat our record of 102 feet.
102 feet. We did it. So many tries, so many attempts, so many failures. But you know what? That was okay. Because we learned so much from our failures.
And who knew there could be so much science involved with just throwing a paper airplane, and a lot of excitement as well. 636-4357 is the phone number. We do have phone tutors most Tuesdays and Wednesdays throughout the regular school year. Programming note, bringing up once again, today the 28th of March and tomorrow the 29th will be the final 2 days of live broadcast for Do the Math this year, our 21st season. We have Ariana, a 4th grade student from Stockdale Elementary, in studio with us, and right now we have another special guest, Amy Smith. How are you today, Amy?
I'm doing well, thank you.
Now you are here because you deal in pottery, correct?
I do, that's right.
And do you offer classes, or you make pottery, sell it? How does that work? Exactly what you do.
Primarily I'm an artist maker, so I make pieces, I make functional ceramics, and I sell my pieces at art fairs and art shows. But I also, about once a month, I offer a class or two every month, in my studio on the west side of town.
And this is Blue Canyon Ceramics, correct?
That's correct. That's
all right, so that way people will know where to go, Blue Canyon Ceramics. And you said functional ceramics.
Yes.
Functional pottery and things. So explain that a little bit as opposed to just pottery or ceramics.
Ceramics is a huge field, and so there's sculpture and functional ware, and what I make in particular are cups and bowls and pieces for your home and for your garden and kitchen.
So that way you can use them on a regular basis.
That's right. Yeah.
And how long have you been doing pottery?
For about 20 years.
So you're pretty good at it.
maybe.
I'm only kidding. You're a lot better at it than I am, I can tell you that. So you've got Ariana, a 4th grade student right there, as your assistant today. What will you be doing today?
So today I'm going to demonstrate how we use math in my studio, and I'm going to be making a bowl. Clay, through all the processes, undergoes shrinkage, a shrinkage rate. So if we wanted to make a piece of a given size, we have to calculate for that shrinkage through the drying and firing processes. So we need to increase the size of our piece. If we want to, say, a 6-inch wide bowl by a 3-inch high bowl, we need to increase that. And this clay here is 13% shrinkage. So we need to increase our piece when we make it on the wheel by 13%.
All right, well, you ladies, take it away.
Okay, all right. So like I said, oftentimes we want to make a piece that is a certain size. So in this case, I'm going to use a bowl that is 6 inches wide by 3 inches high. And this is our bowl. We're going to try and make maybe an ice cream bowl or a cereal bowl. And we want our width of the bowl to be, the diameter to be 6 inches here. That's the width of the bowl. And then the height of the bowl, we want it to be 3 inches. And as I mentioned, clay through the firing process and drying process, it shrinks. And each clay body that we use is a different shrink rate. Well, this clay is 13%. So when I make my bowl on the potter's wheel, I need to account for that shrink rate. So what I need to do is I need to increase this dimension by 13%. And I need to increase this dimension by 13%. So that in the end, I will have the size of bowl that I want to have. And so how we do that is first I take that percentage, 13%, and I turn it into a decimal. All right? And then I take that and I multiply that by my first dimension. So 6 times 0.13 gives us 0.78. And so that's the amount we need to increase that dimension by. So 6 plus 0.78 gives us 6.78. And now I do the same calculations to this dimension, the 3 inches. So 3 inches times 0.13 gives us 0.39. And so we take that and add it to that dimension. So 3 plus, 0.39 equals 3.39. And so now I know I need to make a bowl that is 6.78 inches and 3.39 inches if I want to get a bowl in the end that is 6 inches wide and 3 inches high. Does that make sense? Any questions? No? Okay. All right. So now I'm going to sit down and attempt to make this bowl. All right. And just ask any questions.
No.
Okay.
Well, I've got a question for you, Amy. As you
Okay.
get ready to get going there. How long
Okay.
did you have to practice until you were able to go, all right, yeah, I'm going to be able to make this pretty much on the first try? How long does that take to acquire that skill?
Let's see. I mean, it's hard to say. I've been throwing pots for about 20 years. So in practicing for this afternoon, it took me about 4 tries. But I have a measuring tool that I use. So when I do want to make a pot or a bowl of a specific dimension, I use this arm. And this arm, I set it to the dimensions in this calculation. So it is from the center of the pot to here, it is it's half of it. It's the radius of the pot. So it is, 3.4. And then the height of the pot is the 3.39. So I already said it there. So it's kind of a cheating tool. All right, so making the pot. All right, this is a lot of pressure, but we got this. All right, so first thing I'm going to do is center this lump of clay here. Because when I teach classes, that's actually the hardest thing that people struggle with, is getting this lump of clay on the wheel perfectly centered. So we use a process called coning up and coning down. So this is the coning up part of that, and this is the coning down. And what that does, every time I bring that clay back down, it becomes a little more centered. And centered meaning we just don't want to see or feel any wiggles in this clay at all. It has to be perfectly centered because that makes the walls of our bowl perfectly centered. Perfectly, the evenness all the way around. All right. So you can see this is just about right there. Okay, so once we get our lump of clay centered, you find that point right in the middle there, and you make a hole, and you drop that hole down. That's right in the center of that lump of clay. I'm going to put a little water in there. Decreases the friction. Now I'm going to drop the center. I'm not going to go all the way down because this is going to be the bottom of our bowl. So I leave about ½ inch of clay down there, and now I'm going to widen the base, and this is the bottom of our bowl. So I have the bottom, and now what I'm going to do is I'm going to make the shape of the bowl. So I do that in 2 steps. One is bringing the height up, and then the next is coming out. Okay, so I'm going to I'm just squeezing the clay, and I'm getting height out of that. And so remember, my goal is to make this clay come to my measuring tool right there. So that is the dimension. All right, so I'm going to come up a little bit higher than my measuring tool, because once I bring the bowl out, I lose a little bit of that height. So you got to take that into account. All right, so I'm a little bit past it. That's my height. And then what I'm going to do is bring the top out to my measuring tool. And I'm keeping my eyes right here the whole time I'm watching it as my hands are doing the work. So I'm coming out, and I'm not going to touch it, but I'm going to get it right up to it because I still need to shape the sides of my bowl. And I'm going to slow my wheel down a little bit as I shape. So I'm going to use my fingers to I'm going to bring the inside of my bowl out and give it that shape on the inside. And so I got most of that work done, and we have these handy dandy tools here. And so this is called a rib, and I'm going to use this nice arc to give the inside of the bowl, the shape. I'm just going to smooth that out. And now I got the inside. So now I'm going to try and bring that edge right to my tool. And once I get there, then I'm done. I'm going to take the water out of the middle. And that's essentially it. So if you wanted a set of 4 bowls that end up being 6 inches wide by 3 inches high, this is how we calculate it, and this is how we make it.
Well, nicely done. And I wouldn't say that that's a cheating tool. That's simply a tool of mathematics right there, Amy.
Okay, all right.
So how big an object can you make with that wheel and what you've got? Like, could I make a big salad bowl on that?
Yes, of course, yeah. I mean, I've made objects that are about 2 feet high, maybe a little less. You know, big planters or big vases. You start with a bigger mass of clay.
And you said that clay has 13% shrinkage.
That's correct, yeah.
Is that the most common type, or are there a lot lower, a lot higher?
That's pretty much the max. Maybe it might clay body go up to 15%, but it can be as low as 5%. 5% to 15%.
Okay, and is there a certain way you need to store the clay before you use it?
There's not a certain way that you store it, but there is something that you do to prep the clay to use it on the wheel.
And now that you have it done on the wheel, what would be the next step? You're not going to do it today, but what would be the next step?
So the next step is we cover this, we let it dry out to, it loses a little bit of moisture and it becomes what's called leather hard. And then we flip the pot over and we work on the bottom, trimming the feet and maybe doing some carving. And if this were a mug, we would attach the handle at that stage. And then after that, we let it dry to what's called bone dry, where it has no moisture at all. And it goes through its first firing at that point. And then it comes out of the kiln. That's about 12 hours for that first firing. It goes up to 1,880 degrees. And then we're able to glaze it. And then we put it back in the kiln for another 12 to 18 hours, and that goes up to about 2,200 degrees, and that's the final firing.
All right. So there's a lot of pride that goes into when you're making these, right? Because you're putting a lot of time into these.
A lot.
And when I go to places and I see these, they're just extraordinary how you guys are able to make these. And once again, you're at Blue Canyon Ceramics.
That's correct.
And if somebody wanted to find out a little bit more, is there a website or any other?
I do have a website. It's bluecanyonceramics.net, and I would say social media on Instagram. It's bluecanyon_ceramics_co.
All right. Well, thank you very much for coming in today, Amy. It was truly fascinating seeing that process right there. And just the beginning of it, because there's still a lot more to have that become a final bowl or pot right there.
That's correct.
We'll be back with more right after this.
Thanks.
Hi, I'm Ebony.
And I'm David. And today we're going to show you how to make 3 sensors using household supplies.
And you should be able to get all these supplies at your local discount store.
Usually when people think of sensors, they think about smoke detectors, thermometers, or even the speedometer in a car. Sensors can seem pretty challenging when you make them, but today we're going to show you how to make a few simple ones.
We're going to start with 3 beginner level crafts that are like sensors. And if you can follow along, you'll be on your way to creating more complex sensors like this one.
Basically, a sensor is a device that detects or measures a change. This first sensor is pretty simple. It's going to allow you to be able to detect if your brother, your sister, or even if your cousin entered into your room.
That's cool. I'm really going to like this one.
For this activity, you'll need a balloon, a tack, and some tape. Let's get started.
I really like that one. How is that a sensor?
Well, the balloon and tack act as a motion sensor. Opening the door produced the motion. The balloon and tack alerted you to that motion, and that's what a sensor does.
That's a good way to look at it, David. So for our second sensor, I'm going to show you a colorful way to detect if someone opens a drawer, whether it's a cabinet or a desk. This one is going to be good.
That sounds awesome.
All you need is a crayon, a piece of paper, and some tape.
Aw, man, she got me. You know, Ebony, I like that one. The person who opens up the drawer may never know that they were detected.
Right. Sensors don't always have to emit a sound. As long as the sensor detects the motion of the drawer opening, you got a winner.
This last sensor is one of the simplest sensors yet. You can use it on a door or even a drawer. For this, all you need is some aluminum foil and some tape. That was fun, right?
Yeah, it was so easy building those sensors. I feel a lot more confident because I feel like I understand sensors better.
And that's our goal at Next Gen STEM, to help students build their STEM identities.
NASA innovates for the benefit of humanity by improving life on Earth through climate and technological innovations. In fact, a new future of air transportation is in the works at NASA, and it all starts with sensors. Sensors ensure that flight is sustainable, secure, and safe. In the future, more aircraft will be autonomous or self-flying. In fact, uncrewed vehicles, or drones, are being used right now as package delivery vehicles. They provide emergency response, perform rescue missions, medical drops, conduct aerial photography, and much more.
If you enjoyed making sensors with us today, you will enjoy our Sensor Solutions activity. In this activity, you will understand how sensors work and how they provide benefits to us in society. We can't wait to hear from you.
We want to hear about your successes
Your failures,
and your science.
because after all, you are
The next generation of STEM.
Well, that was pretty awesome of Amy to come in and talk to us a little bit about creating some pottery right there. You were right there. I mean, that's pretty awesome to see that and stuff, right?
It was.
It's a good thing that she didn't have me over there and I had to stay over here because I know she was talking about throwing clay, which is probably the professional term when they're doing stuff. But if I had gone over there and got my hands in there, it would have been smashing clay, flinging clay, spraying clay all over the place. Because I'm sure that after a while it takes a delicate touch to know how firm or something like that pressure to put on that clay like that.
Definitely.
So, you think you'd like to try that sometime?
Yeah.
All right, cool. Well, that's the attitude to have. Yes, I would like to try that there. So Ariana is a 4th grade student in studio with us today. Did some division, checked it with multiplication, and we're now going to move into a whole new world for you. You ready for this? Head on over to the board. This is a little something from our friends at UCubed. This is called the 4 fours. So Scott, if you'd be so kind as to put up 4 fours. And Ariana, we're doing this for you today because you're in 4th grade. So tell us what you know, first of all, about order of operations. Don't even worry about what's on the board. What can you tell us about order of operations?
Order of operations, PEMDAS, parentheses, exponent, multiplication, division, addition, and subtraction.
All right, good. Have you ever heard of something called GERMDAS?
Yes.
All right, good. So that's a little something also. So I'm glad that you're familiar with both. So what I'd like you to do is select a number between 1 and 10. And say it out loud when you know it.
6.
6. So we're going to make all of that equal to 6. So here are the rules, Ariana. You have to use 4 fours. You have to use all 4 of those fours. In between each of them, you must put an operation. Either add, subtract, multiply, divide. Take a root of one of them, right? So there's different things you can do. So you have to use all 4 fours to make them equal to 6. And if you get stuck, Scott will kind of help you out a little bit, but he's not going to tell you what the answer is. All right? So you go ahead and start and explain to Scott your process and what you're doing and why you're doing it.
Well, I don't really know what to start off with.
Okay, well, let me give you an example of something that would not be correct, but we would be able to do the process and follow the instructions, okay? Let's say you put an addition sign between all of these 4s. What's 4 plus 4?
8.
8 plus 4 more?
12.
12 plus 4 more?
16.
16. So that is one thing you could do. That would be allowed because you'd be putting a plus sign between all of them. You'd end up with 6, right? Well, that's too high. So maybe one of them we could do a minus sign, right? 4 plus 4 is 8, plus 4 is 12, minus 4 is 8. That's getting pretty close. So you can move things or you can use different operations, do whatever you want to do so that the answer is 6. And so if someone looked at that problem and they worked it out, they would get a 6. And this can be approached a couple different ways. You can look at it and think, maybe I have a plan. I'm going to think about it for a while. Or maybe you could just jump right in there and put some operations in between and see what happens, because you have an eraser. That part's kind of nice. Any ideas about how you can end up with 6? Because we know with all addition, we ended up with too high. We did 2 additions and 1 subtraction. We're still too high. What else could you do?
Division, multiplication.
Division, okay. So what do you want to divide? Want to give it a try? Aha, so 4 divided by 4 is 1, right? Mm-hmm. Okay, what are you going to do next?
Let's see.
We still got to get a 6, huh? Tell me what you're thinking in your head there. If you did 1 plus 4 plus 4, that's 9. That doesn't work. What else are you thinking?
kind of try dividing again.
You divide again? Okay. Which one's you going to divide?
Well, 4.
Okay, so tell me what you would get if this was the case. What's 4 divided by 4?
1.
1. What's 1 divided by 4?
1 divided by 4 would be 4.
Not quite. Other way around, right? 4 divided by 1 would be 4. What's 1 divided by 4? You'd have a fraction. Or a decimal. You'd actually have 1/4. As fun as fractions are, don't get me wrong, I love me some fractions. But as fun as they are, I don't think we want to go to fractions in this kind of problem. Okay, so let's go ahead and avoid that one. So that was a good idea, but maybe we don't want to do any more division yet. Maybe later. What else can you try?
I can try plus
Sure.
addition.
Go ahead. So what do you have now?
I have 4 divided by 4 is 1.
Uh-huh.
Plus 4 would be 5.
Good. Now, are you following the order of operations if we do the division before the addition? Are you following them?
Yeah.
Oh, we are. Okay, so that's a good thing. That's important to be able to do. So can you make this 5 and combine it with the 4 and make a 6?
Well, 5 plus 4 would be 9. So.
Yeah, that doesn't quite work, huh? Still thinking. I like it. I like it. Keep thinking about what you might want to do. Do you want to take those operations and move them around anywhere? Because you don't have to do addition first. You could do division first, right?
Yeah.
Right? I mean, we did division first, but you could do this a different way. If you put some parentheses in there or something. What other ideas do you have? There's no wrong. We're just going to get there eventually.
I'm honestly not quite sure what I want to put in.
Okay, well, let's see what happens here. What happens if you move that division sign and put it there?
Well, it would still be 4 divided by 4.
4 divided by 4. There's 1 there. Could you do anything with the 4s on the outside part?
You could do additions.
I don't know. Let's see what would happen here if we did like this. If we switched them up, before we had division and then we had addition, right? But now we switched the order of them. Tell me which part of this problem you would do first.
The division.
You do the division, and we'd be right back to where we started, right? You'd be 4 divided by 4 is 1, and 4 plus 1 is 5, and then you still can't get to 6. How can we make it so that you have to do that division first? Because right now you don't. Right now you have to do the division first. Is there a way we can make it so that you have to do the addition first?
Parentheses.
Ah, there you go. I don't know where this is going to go, but that would change the order of operations, which is kind of what this problem's about, right? Okay, so what happens now?
Well,
What's 4 plus 4?
8.
8. Okay, and now we have 8 divided by 4.
Which would be 2.
That's a different number. Before, all we were working with was 1 and 4. Now we have a different number. So do you see where this goes? Kind of neat, huh? What do you think you might want to do now? Tell me what's happening. I like how you put these parentheses in there. We switched things up a little bit. It changed the order of operations. And now you have 8 divided by 4. What's 8 divided by 4?
2.
Okay, so put a 2 down there. And then what do you think the last thing is going to be?
Addition.
I like it. So let's make sure that the order of operations is satisfied, right? This is going to be 2 plus 4, which is 6. It looks good. If you kept it just like this, and we're not even looking at this anymore.
Yeah, you've got 15 seconds to figure it
I
out.
like it. Tell me what the first thing is you do in this problem.
The parentheses.
This is the first thing. What's the second thing you do in this problem?
Division.
It is, that's right. And the last thing?
The multiplication.
And if you do that right in order, it looks like you end up with 6. That was good experimentation.
All right, Ariana, come on over here quickly. So that was nicely done with the 4 4s right there. So did you learn a little something today?
Yeah.
Good. I think you learned quite a bit today. Did you have fun today?
Yes, I
That was the most important thing right there. It's always good to come on TV and have fun, right? Put it there. Nice job today. Hey, tomorrow's the last day of live broadcast for Do the Math until next year. And until we meet again tomorrow, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.